just realizing like, oh, we're doing this thing together and we're in this together and like we're excited to figure it out together.
That was really refreshing to be in a situation where I didn't feel like I had to pretend like I had all the answers.
There was a sense of like childlike play. Did we all just become best friends?
Hey friends, welcome to another Dreams of Education podcast with me, Kelly Tenkely, and my friend and co-host,
Michelle Baldwin.
And Michelle, today we thought we would talk about math specifically, but I know it's going to grow legs as everything in our world does because we think in inquiry. And so often we'll start in one place and then pretty soon our conversation has all these connections that might be a little bit unexpected for people. So I thought we would start by just purely defining what is math, because so often at Anastasis, kids would go home and say, we don't do any math at school. And it was because it didn't look like the worksheets that they were used to, maybe from a previous school experience or from something else they had seen. So what is math, Michelle?
I like to define math because I think that's where people get in trouble. I think there are definitely components that you can say these are mathematical ideas. I think what a lot of our kids were thinking is we didn't do anything that was computation today. No addition, subtraction, any of those operations, right? Or it didn't look like you said with worksheets. Could have been logical thinking. There's our website, Which One Doesn't Belong? And is that Christopher Danielson?
We love that website.
I think that's who that is.
I think you're right.
Should maybe do more research before I talk about people.
I know. The problem is it pops in and then
right?
I am thinking that, right?
Yeah.
So.
Yeah. I think that his handle is like Triangle Man.
Mm-hmm.
That's the kind of thing too, that when you're looking at, those of you who've never seen that, it's wodb.ca. And we can add that to the show notes too. But you go in and you can look at all of these different topics and shapes, for example. And then there's like a grid of 4 squares. And then inside each square is a shape, for example. It could be a number, it could be dice, it could be pictures. And then you pose to the class which one doesn't belong. And the best thing about these is there's no one right answer. And
it's my favorite.
It is.
To see the kids like, I see something different, like the perspective that they take and the way that they see it.
We used to have like the littles, like 5 and 6 year olds doing this. But my favorite time was when we did write the older kids. So the oldest kids in the school would be like 14 or 15 years old.
Yeah.
Bring them down into the littles classroom and have them observe the littles first. Yep. The first time they ever did that, the oldest kids, they were like, I didn't see that at all. I would never have seen that. And, our littles were just riffing on all of the different ways that something didn't belong. So that's math. That's, we're still looking at things in a logical way. There are, they can be saying, oh, well, if there happened to have been like 4 triangles in the grid, they would be able to remark that, well, they're all triangles, but this one is a right triangle and all the others are not. Or this one is shaded and the others are not. So they started looking at attributes.
Yep.
We're able to introduce really incredible mathematical terminology during those times too.
Yeah.
Somebody would say, oh, well, that one has the top point at the bottom and its base at the top. So then we were able to talk about the term like a base, but then we could also be saying like this is flipped or this is reversed or this is rotated. And we were learning a lot of really great math terminology while doing an exercise that didn't seem like we were doing math.
And it almost felt like a Hidden Pictures from the highlights magazines, right? Where you're like looking and you're seeing things differently or those puzzles where it's, how many squares do you see? And it's squares within squares. Mm-hmm. So there's the, what seems obvious answer, but then there's this nuanced answer of all these other squares that exist within that big square. And I always loved when we had the kids actually then, they do it several times and then they'd create their own, which one doesn't belong. And they would share with the class. And that thinking is so complex for a 5-year-old. I mean,
Right.
let alone for adult, but like a 5-year-old is doing this very complex reasoning and thought process to create their own which one doesn't belong. And they were brilliant at it.
Sometimes they were drawing it. Sometimes they would use manipulatives to create them, Lego, or any of the things,
yeah,
right?
I was remembering like pattern blocks.
Mm-hmm. Cuisinart rods. Yeah. And the hard part for them at first was, well, they all have to have something in common. And then can you find a way where one thing is not in common? And that was the way we would start that exercise when they built their own, because that it was too much to say, okay, find, numerous ways or multiple
Think
ways
about
for
it
this,
all at
right?
once.
So that we could step them into that and helping them again to think logically about what the problem was and then to create that. And it was so exciting when they're like, well, I only tried to do one, but I found two. I'm like, oh, well, great. So they were really able to kind of move along into that progress and that process and then think through not only how they were going to present it to their class, to make a grid, are they going to use their iPads and take pictures, or were they just going to place it on a piece of paper that I gave them that had grids on it? And then it was kind of like centers that they could all walk around to view each other's. And we would, again, share that with another class and have them try to see if they could figure it out. So you said empowering. They're really getting some difficulty levels that are naturally differentiated, because for some kids, it might have been, I can only find 4 things that have something in common, but one thing is different. And then for others, they might have stepped it up to 2 or 3 or multiple ways.
Yeah. And how often they were looking at each other's and realized that they had created more which one doesn't belong than they intended to. Right. And it was like, oh, I didn't even, it was the excitement of like, I didn't even see that.
That's a great activity that we could do. And we did that every year. That's one of those that even if you're using the same grid multiple years in a row, you'll still get different answers from different kids. And I love that, because that really helped me to see how their brains were working. So I'm, watching who's really struggling with recognizing shapes, for example, or who knows all of their numbers or and evens, just any of those kind of things.
Yep.
There were multiple standards being taught in that one lesson. I shouldn't say taught, multiple standards being learned in that one lesson.
Yes.
And it was really able.
That was a good distinction.
It was able to then see where I needed to create more activities for different kids and really make sure that everybody's needs were being met with just that one simple activity.
Yeah. And what I love about that specific activity is the way that it is so inquiry driven and makes what we do in inquiry in every other area stronger, because they're getting really good at noticing, at calling out distinctions, at, like you said, that reasoning process, which is only going to help them in all other inquiry. So while it is math, it is also these other things. It's also supporting the learning in other ways.
And it goes back to, and we've said this in previous podcast episodes, what do you notice? What do you wonder? And those 2 questions help really put things into place for kids, because there's not a wrong answer.
Right.
And I think that so much damage is done in learning. And I can point to multiple areas, but a lot of it is in math, because there always seems in traditional learning, well, there's just one right answer here. That's not helping.
Even down to, do you remember being in school and getting homework that you'd bring home? Mom and dad would show you a different way to solve that problem. And I would be in tears, because that's not how my teacher showed me. And we have to show our work the way the teacher showed. So it almost becomes so rigid that there's not even a different way to approach the same problem in most math classes.
And when you start to really think about how a lot of learning is structured early on, computation, for example, when they're starting to learn addition problems, we start off right away using that abstract 2 + 2 = 4. We've now taken away the way that brains develop numeracy in general, but also how it thinks about what is adding, what does it really do?
Right. It becomes an exercise in memorization, right? That's where the flashcards come in.
Exactly. And I've told parents for years that yes, flashcards might have helped you at some point, your learning journey. But what we know with kids is if they have problems with memorization, they're really going to struggle in math. And if you keep pushing the memorization without fixing the issue in the first place or trying another approach, they're always going to struggle with math. And that's why we have so many adults who have, baggage with math. It's not that you were bad at math. It's that you didn't have the instruction that you needed when you were learning. So with parents and said, please don't use flashcards, especially for younger kids, because that's not where their brains are developmentally. They need more concrete examples. I know a lot of math teachers talk about CRA method, which is concrete, representational, and abstract. Younger kids, you keep them in concrete for a very long time. And honestly, loved using concrete examples and activities with older kids. That's why we use math manipulatives all the time, because they really help to have, it's that tangible, we're getting multiple sensory input here. And now that I think back to how do we learn math, for so many of us, it was from a textbook and a worksheet. We just memorized. And it was okay that some kids were good at math and some kids were bad at math. And that truly isn't okay.
Yeah. And how many, I think of my husband as an example of this, were not good at or didn't care or believed the message that math just isn't my thing, because it was all that abstract rules, memorization, it didn't have any concrete anything. And then come to find out, in adulthood, actually, I'm great at applied math, right? Like he's really, really, he does machining. He's good at this applied math, but went all the way through school not believing he had the math brain, so to speak. And it changed the trajectory of probably what he would have done had he come to a school like Anastasis, or had he had a teacher thinking about math in different ways, because he thought, well, I can only be an artist because I have this skill, but I don't have math skills. Really, he probably should have gone into like engineering, because that's his love. Like he loves how things work and but math was always hard. And so everybody dissuaded him from that path. And what a disservice we do to all of humanity when we tell kids that it's okay to be bad at math. And, some people just don't have a math brain, which we know is not accurate.
It's not a thing.
It's not a thing. Yeah.
Well, it's like, you have a music brain. No, I have a lot of years of practice and exposure to music, right? Same thing with math. Same thing. We don't let people say, well, I'm just bad at reading.
Yeah. Well, and that's what I love about what Joe Bowler's work is doing, is really breaking down some of those messages. For those who are not familiar with ucubed.org, it is a brilliant site. We use it a lot because it approaches math. One, it first breaks down the messages of there is no such thing as a math brain or a non-math brain. Like it's just a brain. And that she does that growth mindset. We don't know it yet. And she is brilliant. The team at UCubed is brilliant at putting together mathematical exercises that have different answers and different approaches and different ways in. And she helps you think through how to approach math in that way from a teacher standpoint, as well as the activities to do with students. And yeah, we used it a lot, that work a lot in the classrooms.
To having kids hear that a mistake is actually helping your brain learn. And that is true in math. It's true in everything. You don't get something right the first time. And again, we're going back to an answer that was right or wrong, right?
Yes.
You're still learning something and you're not there yet. Your brain is actually growing, and it's creating a way for you to get there that will help you hold on to that concept, that skill better in the future. It's okay. The struggle is where the learning happens. And I love that Bowler and the UCubed websites and activities really are constantly reminding. It's said you need to have these norms printed out in your classroom in some way, shape, or form, because this helps kids to remember that don't have to be fast at math. Right.
I love that she emphasizes that so much, that fast does not equate better at math.
I stopped to think about how many practices have been harmful for a lot of kids in math, because we focus on fluency again, as if that is the goal. When we say fluency, it really should be, I know my addition, subtraction, multiplication, division facts well enough that I can do other more advanced problems that require them. It isn't that I can win at a game of flashcards, or I can go to the board and beat one of my classmates in a math problem.
I hated it. Oh, I hated it. The pressure. I hated it.
There was much. I was in 6th grade, and you can tell that this stuck with me because that was a really long time ago for me. In 6th grade, we would do these all the time, where we'd have these math races. So the teacher would tell us what the problem was.
And it was supposed to be fun because we're gamifying the classroom.
It was a game. We didn't have the word gamify back then, but yes. I remember that the kids would bet that I would win because I was fast. I was a fast processor.
Yeah, I have an excellent memory.
Right. So those things were not hard for me. And so boy decided this time he was going to bet me. He goes, "Hey, I bet you $1 at recess that you'll win." So I just didn't. I was like, cool, I just won $1. But again, I stopped to think, okay, what did that do to the kids who had to go up against someone who was fast and good memory? That's devastating.
Also, for those of us who could do mad minutes quickly, because I was fast but the social pressure of doing that in front of people made me melt down. The anxiety was off the charts.
I mean, we've had kids who cry when it's time for math. They come to us and they're crying because it's such this heavy, anxious thing. And you're like, okay, my friend, this does not we need to undo a lot of damage here.
I think it's the difference between, we talk a lot about not teaching math in the ways that we typically historically have thought about math class looking, but instead, how do we develop kids who think like mathematicians is really our goal. So what skills does that take? It takes us back to exercises, that logic and reasoning and the problem solving like we started with. And it isn't about just memorizing math facts. And I think relationships. So many of our parents automatically associate the memorization, and that's how they know, is my child successful in math? Well, I quizzed them on the way to school and they didn't have their math facts down. And it's like, please don't panic and please don't push that, because it's going to cause more trauma down the road than you know, and it's going to create more roadblocks the more difficult that the math becomes.
And some of those same parents who were quizzing their kids constantly also would come and say, admittedly, I'm bad at math. And I'd say, okay, let's kind of parse that out a little bit and say, I don't think you actually are bad at math. I think that you have some negative emotions surrounding what happened to you in math instruction. And again, I'm not faulting teachers.
That's
because
a really good distinction. Yeah,
absolutely is. I'm not faulting teachers here, because a lot of our math teachers have been taught to teach math in a certain way.
Well, and the curriculum dictates it a certain way, right? We're using curriculum that says this is what it looks like, and this is how it's paced, and this is the order that we teach it in. And there's so much about it.
Expecting every kid to do the same thing at the same time, and that does not work. When I've seen boxed curriculum taught well in a school, when the teacher was able to have the freedom to do some natural differentiation, to work in groups with kids, to realize that some kids weren't in the same place, but because it was still, I wouldn't say racing guides, but they still kind of had to be in the same place as the other teachers in the district, which don't have the same kids. Why is that a thing? That's a different topic.
Why is that a thing?
Is that a thing? But again, that's doing the best with what you're able to do with what you have. If you are forced within certain guidelines, still, you have whatever number of kids you have in your classroom, you probably have that many different levels of ability. They have
that many different, right?
They have backgrounds that they're coming from. You don't again, do they cry? Do they get super anxious? Do they have headaches right before math class? These are signs that we're doing things.
Aches, Michelle. My stomach hurts.
We're doing things to kids that aren't helping learn. We're just doing what we've always done, and that we can't keep doing that. So, like you were saying before, we did some activities that helped kids to think differently. And the best part for me too is that they were gaining some empathy too with each other, because they could see that not everybody thought the exact same way that they did. So subitizing activities, just throwing a bunch of dots up on the wall and saying, okay, how are you counting this? And letting, like if I did on the whiteboard, and they would go up and they would trace around. Well, I counted by threes. If they were like a splat of dots,
I saw it this way. Yeah. Yep.
Then having the kids explain how it was that they were able to count in their head without pointing to each one individually. And sometimes kids would say, I pointed to each one individually and counted them one at a time. But hearing each other talk about that, I never thought about counting it by twos, or it was in a pyramid shape. Counted the points first, and then you figured out the middles. So it was really wonderful listening to those different explanations of how they did it.
And helps develop, like you said, the empathy, but also we may be looking at the same thing, and our reality of how we're understanding it, the perspective is different, which again is so helpful in life and inquiry, because that is such a necessary skill for all of us to realize our baselines are not always the same. The way we're thinking about looking at the exact same thing, and we're going to come up with different ways of thinking about it. And it is so interesting, even as an adult, to hear the kids talk about how they're seeing it. And it gives us so much information when it's like, oh, we know that they struggle with short-term memory, back to the cognitive skills piece. And so the way they're counting one by one makes sense, because they can't hold in their mind, there's 4 in the center and however many surrounding it. It just goes back and shows us that cognitive skills ability again, where we're seeing the reasoning behind why a student might be slower than when it comes to the computation, because it's revealing some of that.
It also goes back to, okay, what are we actually trying to get kids to understand when they're learning even the most elementary basics of mathematics? And I think back again to some activities that I did with kids. We were out measuring wall outside of our classroom because we were going to put up paper so that we could display our work. And we wanted to cover the wall in paper, like a background. And we needed to know how much paper we could use. We didn't want to waste any. So we were talking about measuring it. Well, it was longer than the measuring tape allowed. So I had 2 kids in that classroom who could add multi-digits together. And I had some that did not. So we figured out, oh gosh, well, we've got it was like 180 plus 30 or something like that. And one of my kids figured it out in 10 very, very quickly. While the ones who, and again, quickness was not the issue, but the kids who were trying to write it down, make sure that they had their 1s and 10s and 100s. Again, those were 6-year-old kids. That was pretty advanced for them to be able to do that. But at the same time, they chose the much more difficult path because they thought that you could only add numbers in a certain way. When we broke it down and said, well, this one over here thought about it in base 10. So if 180 is 1 100 and 8 10s, and then you add 30 more 10s, they're like, oh, again, it was
way easier,
right? It was just another way of thinking about what addition is versus an algorithm. And that I think has been one of the toughest things, again, with math, when we look at it in terms of math instruction, not focusing on algorithms to the detriment of what's actually happening.
Well, and to your point, what I like about that is as we're engaged in an inquiry block, they're thinking like mathematicians, which means they're starting to see and notice the math, even if I didn't explicitly put it into a block. like we talked about the patterns, where they started to notice the pattern, the spiral pattern, as they were bringing in pieces of nature.
Pine cones
became, right? And the sunflower, they dissected, and looked at that. And that's really what led to them discovering the Fibonacci pattern and getting so excited. We talked about that in a previous episode, but getting so excited about how that works. I didn't put that into the inquiry block. It was, they're primed for thinking like mathematicians. They're noticing things. They're asking good questions, which then allows us to bring in concepts that would never be in the standards for whatever grade level that is, right? And so it's, like I said, it kind of grows these legs and just goes everywhere. It becomes this web. But a lot of it has to do with starting with the noticing and wondering, the thinking about there's probably multiple things going on here, and not getting so locked into this is the rule that my teacher taught me that I have to do it in this way.
One of my classes when I was teaching, I think they were like 9, 10, 11, 12, that age. And a couple of the kids had been learning about angles and then degrees. And that was a really difficult concept for them. They were really struggling. And then in our inquiry unit, they were doing some things with nature. And one of the students was reading about owls. And she learned that owls could turn their heads 360 degrees. And then she was like, wait, I could see the wheels turning, right? And
ding,
she
ding,
was
ding,
like,
ding.
So a circle would be 360 degrees. So half of that would be 180 degrees. She goes, oh my gosh, I get it. So again, these are the times within the inquiry that because we're not completely separating out every single content area, she was able to then go through and say, I'm making a connection to this. I understand it. So we didn't have to say, oh, wait till 2:00 because that's when we do math.
And it's in context and it's applied and it has purpose. And I think so often, unfortunately, because of how we were all taught math, and we don't all have your brain because you're brilliant at noticing this yourself, it can be hard for us as educators to capitalize on all those moments because we were not taught to look at math in that way. We were not taught to think like mathematicians. We were not primed in the same way. And so part of it is even our own detox of how we think math has to look and how we're approaching it and asking those great questions. And like Nancy did when she didn't know that it was Fibonacci, she was like, I think I remember that there's a mathematical pattern here, right? And so they all went and discovered it together. And that almost, that discovery together of the in context, the purposeful, it has meaning for what I'm doing right now. I'm making a connection that feels fuzzy, but maybe we can research it together, is I think the brilliance of an inquiry-based education. And post-school, that's what we do. When we get stuck in I don't understand how this is working, that's kind of the path we go down.
And it also makes, like, the kids can understand not every teacher is going to remember every single thing about math that they ever learned. Our brains aren't, that's not how they work. So it was like, there was one time when I was working with some students on geometric proofs. I remember it was just two of them. We were sitting together and we were talking about, okay, here are the steps to do a proof. They're like, well, we have to know all of the properties. And I said, yes, it helps to know that the property, like to know what math properties are, like the commutative property and the identity property, all of those. It helps to know those. But if you're trying to memorize those and keep them memorized all of the time, there are so many of those properties and then proofs that you can then use as proof. You're never going to be able to remember all of that, but you need to know that they exist and be familiar enough with them to go, oh yeah, I remember that one. I can go look that up. And then when it comes time to actually sitting down and proving a theorem, for example, then you are able to do so because you have that familiarity. I said, I still have to look those things up. I can't memorize all of those. Plus that was, when I was in junior high and high school, it's been a long time, guys.
Been a minute,
but you know how to teach it. I said, yes. because I have that base level understanding of what they do and how I'm supposed to use them, I still have to go back and refresh myself on this. And you're not memorizing everything. You cannot.
It's part of the reason I love the how we express ourselves inquiry block, because it lends itself obviously to self-expression, right? So we often think about like the arts and theater and dance and music and those things, but it also helps kids during that block when we would pull in thinking like a mathematician, approaching something the way a mathematician, like looking at the same thing from an artist's perspective versus a poet's perspective versus a scientist versus a mathematician, and how that understanding of the world around us evolves and continues to evolve. Because I think the way I learned math in school as a list of rules is like somebody's figured this out, or this is just the law of how it works, and your job is to memorize the law. The reality is we're still trying to understand the world through math. And when kids understand that this is an ongoing evolution and process, that not everything has been understood yet, I think that's important. And that is how mathematicians think, right? They're still trying to understand how the world works through this lens. So I always loved that we could bring that in, even into blocks where it felt like it was going to be very arts heavy or humanities, heavy. And we could bring in, okay, how would a mathematician think about this? How would,
look at it as like there's math in everything. And the beauty of math is also the beauty of art. When you look at perspective, that's math. When you look at the rule of 3 in composition of a photo or in a painting, that's math. Sometimes I would have kids go out and just take pictures of things that they found interesting. And then I would say, okay, now tell me about math here. Or I get even more focused and say, I want you to go outside and take pictures that will help you explain perspective. And then I'm like, again, you can use that as...
They did that cool. I still have photos where they did the forced perspective exercise, and they took photos based on the different perspectives and the forced perspective, which was
Sometimes
so
it was shadow of a fence, and they could see the bars were getting smaller. It went further away from the point of the camera. So we could talk about that too. And again, there are ways of doing this. Yes, there are actual formulas and algorithms that you could do to show you're painting something and you want to show perspective. You could even do things to scale. But when you sterilize all of that out, right? You're just taking the very, very most like computational facts of it, rather than showing, yes, there is math in this, but let's look at it else. You've taken out
everything that makes it interesting and worth knowing. Right? Where it's like, oh, why is that happening? Why I noticed this. Why does that happen as the sun moves across the horizon? Exactly. Right? What is happening? What's going on here? When you take away all the curiosity and you've reduced it to just the end result, there's no humanity in it. There's no reason to care about it.
There's no beauty there. Yeah.
There's no beauty. And it makes me so sad that so many kids, myself included, that's how we learned math. Just completely devoid of anything meaningful.
And music is the same way. If I only taught, here's each note, here's the staff, before I ever let a kid sing or play an instrument, it doesn't have, first of all, there's no context, right? I know what a quarter note looks like. I don't know what that means. Or this space on the staff is always a C in this clef. That is so completely sanitary and uninteresting. Yeah. And now if I go back in and say, okay, you know what, we're just going to play instruments. And then eventually as they move along, and we've been doing all of these patterns that they know, now I show them what notation looks like. It's the same thing that we were talking about with concrete, representational, and abstract. It's how I teach music. There's a whole, like Carl Orff said, hey, here's how you should teach kids music. And that is still that method that many, many music teachers use now, because it has kids making music before they start figuring out all the notation. We don't teach language. Oh, sorry, infant, you can't babble until I teach you all your letters, right?
Yes. And until you can speak in whole words and complete sentences.
Don't make any of those sounds because that is so vital to learning. So the way that I teach music is also the way that I look at math. And when you were saying earlier about your husband and how he didn't think he was good at math. He was just an artist, or they told him he was just an artist. I'm like, there's so much math and art that even
there's
if you
so
don't
much.
see it, right?
Like what a lost opportunity to help somebody see how it's all connected.
And all of this to say, it's not always honest us is we're not just, constantly looking at the beauty in math. It sounds a little, fuzzy and maybe a lot of focused goals. That's not the case at all.
It sounds a little hippie. Let's just call it what it is. That's what the parents tell us. It's a little hippie.
It's not just always that. So when you get kids kind of hooked and you have their interest and you've got some really good provocations going, then when it comes time to practice facts or practice looking at angles or using a ruler or a protractor, or I have to understand how to balance equations,
fractions,
any of those things.
Yeah.
Now you've got them coming from a different frame of mind rather than I have to sit down and do this thing that I'm suffering through because I really don't understand it, or my memory's not helping me hang on to my facts, or I never understood. I know I use this example all the time, and had a student. It's the same one who had the owl example, by the way. We are using dots to show groupings and multiplication. She already had all of her multiplication facts memorized backwards and forwards. She didn't need to be quizzed. So the example was I gave them all a bunch of manipulatives. They were little red dots. And I said, please take a fact and show me what that looks like using the dots. So most of the kids were grouping. So for example, 5 times 3, they'd have 5 groups of 3 in piles, and then it would show 15, and they were able to explain it to me. She took her dots and made a 5 and an X to show the operator, and then a 3, and then an equal sign, and then 15. And I was like,
she had no conceptual understanding of what multiplication was.
Memorized everything. She just didn't tie the 5 times 3 to what her conceptual understanding of multiplication was.
Sure.
So when I said, hey, let's look at it this way. So I made 5 groups of 3 for her. And then she looked me in the face and said, is that what multiplication is? And I said, yes, because nobody ever told me that. And I said, I bet that they did. It just wasn't sticky because of how it was introduced. And she was like, oh, from then on, again, she already knew all of her facts. What she was able to do and apply that new knowledge to made her so, again, empowered, but so happy because she was like, oh, this makes so much sense now.
I mean, it was me. I went through trig, got an A. God knows how. I don't know, actually, because I was good at memorizing the formula and passing the test each week. I had no idea what on earth trigonometry was used for. I had no idea how it was useful or applicable in any realm of my life. And I remember watching the Social Network movie when it came out, and we're sitting there and I'm watching him write an algorithm across the window. And I'm like, that's a trick. I learned that, but I had no idea what it was like. How is that possible to get through all that math and not know what it's for or how it might be useful? It's such a disservice.
Like the different kinds of building and things that we had kids doing where they needed math. Again, it wasn't necessarily that math was the target focus for that particular activity, but showing kids, again, like the number of people that tell me, well, another day went by and I didn't use any algebra. And I'm like, no, I bet you did.
Right.
In some way, shape, or form. And maybe you didn't if you just, there are some days when we don't do every single thing that we've learned, but just to take that out of context and say, okay, you're going to learn how to do this. There's no way for brains to automatically catch on unless they happen to already have an experience. It's like we've often told people, say, hey, bake with your kids, show them how to use measuring cups and help them think through, oh, this is 1/3 of a cup. This is 1/4 of a cup. Which one's bigger? Because the number of human beings on our planet who think that 1/3 cup is smaller than 1/4 cup.
Right.
And now that helps us to think through.
I will say, the only reason, even if I see fractions and the kids are asking me on paper how do I add these things? I literally am going through my kitchen and thinking about how I would double a recipe or half a recipe or whatever, as I'm helping them, because I don't, I haven't used the rule long enough that I can't go back to that way of understanding, because now I've learned how to apply it. And that's how my brain thinks about those relationships. Or I think about a clock, right? Like depending on what it is. But I really don't go back to, how do you flip it? What do you do? Is this the one where you cross it and flip one? And you learn all these tricks, and the tricks might help you pass the test efficiently on a Friday, but they don't help you when you're in the kitchen the following week trying to double a recipe, right?
Exactly. And that goes back to, again, you have to have a framework on which to build the abstract concepts. So if you're teaching kids about fractions and you're not using something that helps them, like a lot of people will use pizzas, an example. So, okay, well, they're drawing. If they're drawing it, that's representational. You got to go back to concrete. You have to give them something that they can manipulate with their hands to physically touch and see what that really means. Then you can
by the way, if folks have never seen the sum blocks, or I know they're the Montessori wood blocks are similar, that each number has a different height. And when you stack the numbers, it shows kids how to balance an equation, right? But even our youngest kids would start to notice, if I stack 2 5s, it's the same height as the 10.
Yeah. It's a great product.
Or if I stack all these 2s, it's the same height as the 10. And they start to see those relationships. And then what you can do with bringing in fractions and understanding fractions, because they're seeing the fraction of the number, even made up in a different way. They're so brilliant. If you've not seen them and you're like, where do I even start doing something like this? I loved using those with the kids, just as they could explore and build and construct and
number is the better base when you're building a tower, right?
Yeah.
And how that starts to help them think through just different concepts of numbers. And there are a lot of products out there that I think that can help kids. And if you don't have financial assistance to purchase those things, there are a lot of things that you can bring in. A measuring cup kids can bring in. Who can bring in?
We used mousse pasta from IKEA year 1 as math counters, right? Like super cheap. And we had endless number of math counters that looked fun.
Well, and I want to go back to what you said about the rules, because there are so many rules in math. A lot of them we learn as this is just a given. So I like to always take them apart and say, okay, let's really look at this rule and figure out why it is a rule. So it said earlier about, balancing equations and using manipulatives and sum blocks. You can also talk about the fact that the equal sign does not mean that the answer is coming next or after the equal sign, that it has to be a balance on each side. Why? Yep. And then we'll start to if I have 2 nickels, using coins that most kids probably aren't ever going to use in their lifetime again, right? But they're great. They're great learning tools. So I have 2 nickels and a dime. Well, if I put them on a scale, the 2 nickels are going to weigh more, but their value is the same. And that's where it gets a little tricky. So you start talking to kids about, okay, well, why is that the case? And that equal sign in the middle means that each side needs to be balanced. But the truly best learning activities that we did in math, in my opinion, were the ones where we had kids look at the rules, take them apart. Why are these rules? Why is the order of operations the order that you go in?
You were brilliant with that one.
You said why do I, when I'm dividing fractions, why do I flip and multiply? Why is that? And then we would say, okay, well, what is a fraction? And just having kids think through and define that. Well, it's a part. It's a division problem. If you look at it, that's how we even write it out.
Yeah. Yep.
Then they could create these videos, or they could do presentations to the class to explain what they were thinking. Howie Hewa does this on his YouTube channel and it is brilliant.
Brilliant.
Often would show some of his videos, or told other teachers to do that too. But then to flip that, then after the kids see how we do an explainer, then I say, okay, now you're going to take a rule and I want you to make an explainer of why do we flip and multiply when we're dividing fractions? First of all, tell me what we're even doing. What's the process? Why would we do this?
Okay, so I got to see all of this firsthand, see you do this firsthand, see our teachers do this firsthand. And then I would have parents come in and say, I want my kid to be doing math the way I learned math. And I wanted to cry every time because I'm like, you're asking me to, you don't understand the level of thinking and processing and problem solving and understanding the problem that your kids are doing that is far and away more complex than what you were asking me to do with your kids.
Depths of knowledge.
A lot of times it was, again, their own math trauma, that they have their own insecurity. And then they would bring their kids to Sylvan or Kumon to have them tested to see how they're doing. And first of all, parents, please, for the love of God, they're trying to sell you a product. Like, they're going to find a problem. I don't care how brilliant your kid is, they are going to find a problem and they are going to be the solution because that's how it works.
That's how they make money.
Secondarily, they're fundamentally testing something I do not care about, nor should you, because it's not useful. And so they'd spend all this money sending the kids through these programs, and it doesn't move the needle because fundamentally it was a cognitive skill issue that was underlying. They don't have that skill set to memorize in the way that you're being asked to memorize. And so it was so frustrating from my perspective, seeing the brilliance of what was happening in the classroom, trying to convey that to parents who are still in this mindset of math looks like me being able to quiz my kid on the way to school. And because they struggle with that, they must not be good at math. And it's like, gosh, we have to start thinking differently.
And your kid understands concepts. No, he does not know all of his addition facts yet and subtraction facts yet as a 6-year-old. But look what he just did with figuring out how much paper I need to cover this wall. So what is it that you really want?
I'm thinking of the kiddo who you all were doing an exercise and it had nothing to do with symmetry. The exercise you were doing, I think you were just naming shapes and noticing how many sides and how many points. Is that
we were looking at patterns of triangles, and we started with a dot and then 2 dots, and they're like, well, that's just a line. And then we would do 3 dots. And I said, okay, what's the next? If we're making, this is now becoming a triangle, what's the next number of dots that have to go into the sequence? As we did that, and always asking, what do you notice? What do you wonder throughout that activity? And one of the little guys goes, well, I noticed that if we have different shapes up there, if they have an even number of points around the sides or their corners, or what I think was corners, so that you can fold them. He would use his hands and say long ways or short ways. And I said, so then I would use my hands to say, oh, you mean vertically or horizontally? So again, we could get that terminology in there, kept repeating that. And he goes, yeah. And I said, so, and then what do you notice when it's not an even number of points? He said, well, then you can't, it's only one way. So that's points of symmetry, which again, I don't think I learned until I was in maybe.
This is a 5-year-old. Yeah. In my life, Michelle, it did not occur to me that even you could fold different ways, and odds would only, it has never occurred to my brain to even see it that way. But because of the approach we were taking, here is a 5-year-old who has just noticed a pattern and been introduced to horizontal, vertical lines of symmetry.
And we had been folding paper the day before. So there was, again, context as always, because right. But yeah, that's typically an intro to geometry, or maybe I haven't been in high school for a while, but that is a geometry class topic. And this was something
clearly
he
it
noticed.
Didn't sink in for me, because when he came to show me that, I was like, well, this is brand new information and you, sir, are brilliant. Yeah, it was.
again, it just goes back to what are we making space for kids to show that they're learning and the connections they're making. So again, if I'm teaching a class specifically with that point in mind, and I don't give them any context ahead of time to start doing some folding, they're not going to get there necessarily. Right. Some might.
And the collective intelligence that's happening as a result of them saying these things out loud through math talks is brilliant, because not only did that child, grow from that moment, it wasn't a transaction just between teacher and one student, right? The entire class is participating and going, oh yeah, I see that, right? So suddenly all those different perspectives are colliding in the classroom. All those hunches are coming together, the vocabulary being developed together, and everybody becomes smarter as a result of these micro moments of like connection and understanding.
Even if some of the kids didn't connect to that moment, right? Because it was a math talk, it was a group activity. Even if only a couple are like, oh yeah, I see that. If one was like, no, I don't see it yet, we still had more folding activities we were doing. They were doing some origami. We were working with different, losing the word when you make the shapes out of shapes.
Tanagrams?
Thank you.
I am shocked that I could do that right now.
Words sometimes just fall off a cliff in the back of my head, but that's okay. So all of those kind of activities then play into their understanding of that. I didn't say, okay, now we're going to define what points of symmetry are. We didn't do that. Yeah. So what I hope happens, it's not just hope because we see evidence of it. When we have these little moments of connection, even if we don't dive deeper into that, as they get older, they're still spiraling up from those experiences.
Right.
Honestly, the most interesting thing to me is watching those kids get older. Even when they didn't consciously remember that activity, yes, they still knew. They're like, yeah, I think I know that. And they could explain it. Mm-hmm. Even if they didn't remember the activity they did when they were 5. So,
yeah, of course.
It sets a foundation when they're having these opportunities to work with and play with and understand some basic concepts. When we have parents who are like, no, I really want them to learn like I learned. One of the things that we've done is to say, I hear you. We really feel that they're getting a very rich experience. If you feel you want them to work on some worksheets, here's a website. The Common Core worksheets it has hundreds, probably thousands of worksheets, right?
Yep.
Help yourself. If you need us to print them for you, we're happy to do that. I'm not going to take out classroom time to only focus on that because that would typically be homework anyway.
I appreciate that you say that, because a lot of times what I would share with those families, because we knew the cognitive skills and those foundational pieces that kids have, we had that cognitive skills screening. I knew your child's going to have an enormously hard time with memorization the way that you learned with a traditional flashcard. What we knew through our partnership with the Nectar Group is the best way to build that, because they may not have that visual memory, is to actually have the answer on the same side as the card. So they're taking the picture of the whole thing instead of trying, the kids would always describe it as the cartoon guys running around in their brain, like running into each other. Right. So actually putting the answer with the problem and learning it that way, rather than this constant trying to stump where they can't recall it the way that the parent is hoping. And some of those tricks and tips really helped families who were hyper focused on that one area. And again, it's not to say that fluency and the ability to recall facts and to understand how that's working, it's not to say it's not important. It's not the most important. And most math classes have made it the most important. And so, yeah, that dissonance between what we were trying to do and what was, what parents sometimes thought needed to happen could be a rub.
It's changing how again, perspective, and then you can use that literally and figuratively, right? When we're saying, like you just mentioned, it's not the most important part to us. We do focus on these things. You cannot go on and do, if this is something that's in your path for high school or middle school, you cannot go into algebra and still be constantly thinking about what is 6 times 8.
Right.
That's going to hold you up.
But the reality is, and the same thing happens with spelling. If we have struggle with the memorization of math facts, probably spelling is also going to be an area that we struggle having just the memorization of spelling words. What I know to be true in my own life, and as I watch every one of the kids we have ever taught, is the more that they are reading and the more that they're writing, the errors are going to get fewer by way of we're practicing it all the time. And we keep making the same mistakes. We notice we make the same mistakes. Again, that's how your brain is learning that correction, right? When I constantly see the red underline under the same word every single time I write it, my brain is going to start to go, well, let's stop making that mistake, right? We can at least eliminate that one. And the same thing happens with those math facts of when they're using them more regularly and purposefully, the immediacy is going to come.
Well, and even I remember that, especially when I was teaching younger kids, but even some of the older adults in their lives were telling them not to use their fingers to count or to multiply or add or whatever. And I said, no, please encourage them. And I would get the strangest looks. Why would I want my kid to be counting their fingers still? I said, because they still need that tactile response. And that right now is that brain connection. They might not need it forever. It's okay. Encourage them, because if that's still where they are developmentally, that is an important connection to keep making.
And it's telling them that telling you that that's what they need right now. Yeah.
If I'm asking you to go look up something that you know that is alphabetized and it's alphabetized the M's, you're not going to immediately think about M. You're going to sing the alphabet song in your head because that's your context.
At least part of it.
Part of it, right?
Yeah.
Yes.
Yeah.
Or
LN. Yeah.
Yeah. So we think about some of the suggestions that have been made to us about how kids learn. Sometimes those were done in error. And especially for young kids who are still in that concrete stage, or if kids who are still struggling at an older age, if they need their fingers, they should be using their fingers. And then you give them additional activities to use with their hands. So we do the rabbit ears. Say, okay, you and a partner get together and I'm just going to say a number out loud. And then without talking, the two of you have to use your fingers to create rabbit ears that add up to that number. So I'd say 12. And then they would decide how many fingers, without talking, each one of them would hold up. Then they could look around the room and say, oh, well, they have 3s and 4s over there, but somebody over here has a 6 and somebody over here has a 5. And it was just really interesting to see, again, how their brains were thinking. And then they noticed, so I'd say, okay, well, why did it work for this group, but you don't have the same number of fingers on each head? And then they'd have to explain that. So again, it's that tactile experience where they're getting a concrete idea of what that math number means.
I loved, Rachel used to do this activity where the kids always thought, she was teaching kindergarten and first grade, they always thought it was a magic trick, right? So they were like, we're going to do a magic trick. And they'd start with 10 Unifix cubes. Behind their back, they would break the Unifix cubes into 2. And the magic trick was guessing, how many are in your right hand? 2. And so then they had to figure out how many would be in the other hand. And it felt like a magic trick.
How much
they were reading their minds, right? But they loved that activity. And then she could get, as the kids went on, they could get longer. So instead of 10, it might, the goal number might be, 13 or 15 or whatever. But some of those just playing with numbers and playing, it's still concrete though, right? They've still got it in their hands where they could show one set and then the others would have to go, okay, 3 are being held up. Our number is 13, 10, And they loved it. They had the most fun. They could play that game forever. And anytime I walked in the classroom, it was like, Miss Tenkely, come over here and guess how many. They didn't ever tell me the object number, which made it a little bit trickier for me. But they always thought it was so fun.
That also makes me think too about, again, how many times in a traditional math class, how many textbooks are set up to find the answer, and how many times they don't get to find the problem. And if you will ask kids in traditional math classes, what are the hardest problems to solve? They will almost always say word problems or story problems, either one. And I'm like, okay, that's because you've only ever been a problem to solve rather than a problem to find. When you find the problem, you probably already know how to solve it, but you haven't figured out how to find the problem. And so we would do different kinds of word problems where I would start off like a sentence at a time. There are a lot of math teachers who've created resources. You can search for them online and find hundreds of them. To say, okay, what information do we need? Is there any information in this paragraph by the time that we're done that we don't actually need? Let's cross it out because it's distracting us and probably on purpose. And if that's the case, then now what do I need to know? What is the question? What am I supposed to be finding here? What is the problem? And then helping them to think through, okay, well, are there any clue words in here? We would put our math detective hats on and say, okay, well, this term usually means I'm going to add, or this one means I'm going to subtract or multiply or divide or whatever that might be. Oh, this one, I'm going to have to do multiple operations to find the answer to this problem. And I'm like, okay, but you know this, so let's talk it through. And when they could talk through the problem, then they would find it, they could write their number sentences and then solve the problems. It's not difficult when that's your norm, when you do that often. Right. If you have a whole textbook of solve the problem, solve the problem, solve the problem, solve the problem. Oh, and here are the last 3 problems are story problems. Not every kid is able to transfer what they already know and are able to do to something brand new if they've never done that before. It is a fundamentally
different skill to
Absolutely
identify the problem than to solve a problem. Right. And it's interesting to listen to professors. I read a lot of books from folks at Yale or wherever, and the number of them that write about or talk about how they get these students who have gotten a perfect score on their SATs, but cannot identify and create a problem. They can solve it.
Time we hear from post-secondary education that students are coming to them ill-equipped in math. What do we do in traditional schooling? We double down on what we're already doing and we just do more of it.
Yes.
Crazier paces.
Yes.
So, and it's still not working.
Parents hire more tutors and
exactly
all of these other pieces. And again, the issue is how we're doing it. It's not that they're not getting enough, or it's that we are telling them that math is only about solving a problem.
Right. It's only computation. We said at the beginning of the episode, a lot of times kids will go back home from anastasis and say, yeah, we didn't even do any math today. And then parents will call or come up and say, I'm really concerned that we're not doing math every day.
Well, and this is what lends them. We should connect those two thoughts. This is what leads parents to bringing their kids to Kumon or wherever.
Tutoring, yep.
Any tutoring, because their kids are coming home saying, we don't do any math, because they're not seeing it. They're not seeing all these things that we're talking about as math, usually only if they've been to another school.
Right. They're used to working in a workbook or something like that. And I said, well, we just did all those problems today. Yeah, but we didn't do it in a workbook. I'll give you a workbook if you want one, but we're also going to do this, right?
Yeah.
And you remember one of our parent universities when I had a classroom full of parents and I said, okay, here's the math activity that we did today with your kids. And they were all like stumped. They said, how, my kid's doing this? I said, yeah, your kid's doing this really well. Well, tell me more. So then we would like get into the conversation of things. And some of them were like, I didn't even think like this until I was in college math. And I said, okay, we're still doing, elementary school math topics here, but the way that we're approaching it is through discussion and exploring and discovery.
Higher level thinking.
Yes. Yeah. And why would we only allow kids higher level or deeper pieces of knowledge? Why would we not do that when they're still developing and can do it? Yeah. So they understand things differently and better. And it was, I do remember that like some of those parents would just leave and they're like, my brain is so fried today. I can't even believe you're doing this with our kids. But it's a good thing to, again, show that cannot continue to go along the path of, well, this is how math is taught. This is how we've been doing it. And then also on the other side of the coin, say, I'm bad at math. Our students are failing in math, the country or whatever. These things can't be true at the same time.
Yeah. And frankly, those narratives are not helpful. Like when we keep repeating the same tired story, nothing changes.
So the United States is not lagging behind other countries in math. The way the perception is, again, wrong. It's how students are tested, which students are tested. The United States tests all their students. It's not, like, again, anytime we have something to complain about, we want to just jump on it. And we're searching for the wrong problem and we're solving it in a way that does not help anybody.
I also think we have not asked the right questions. So yes, searching for the wrong problem, not asking the right questions. And we see this a lot in the ed tech world where we jump on solving. I can't tell you how many tools I've reviewed over the years that are solving the wrong problem. And I get it because that's what the districts will buy and that's where the money is, right? And it's so frustrating because we keep solving the wrong problem.
Number of apps, especially when we first started. So again, for listeners, we started Anastasis in August of 2011. So handheld devices for students were still pretty new at the time. So there were a lot of apps over the years, the last 14 years that have come out, many of them asking us specifically to try them and see what our kids thought of them. They were stuck at that substitution phase of tech integration, where you basically just put a worksheet into an app.
Yeah. And then give it fun characters or fun whatever, or make a flashcard that's now an app or all of that. One of my favorites that I think we found year 1 or 2 was Dragon Box Math, because it teaches algebra, but using no numbers. So it's teaching, what it's ultimately teaching is how do you balance two sides of something, right? And it made it this game that introduces pretty complex algebraic concepts, but in a way that is accessible to even very young students. And it made it fun. I still think it's one of the most brilliant math apps I've seen.
Over the years, again, there were some that I really liked because they were approaching concepts similarly to how we were doing that in class. So it could be used as a center, or again, parents would sometimes say, I would like to know if there are some apps that we could load for the kids to, do in cross country trips or whatever. Right. Yeah. So there were some that I felt comfortable for sure recommending, but there were others that I'm like, it's not helpful. It's really just replicating a worksheet. I can print off a worksheet and save you a whole, bunch of time and energy with an issue on an iPad. If it's not helping kids develop core understanding first, and again, a lot of those apps were great at supertizing, having the kids doing the supertizing, or looking at groupings, and
some of the virtual manipulatives were great.
Right.
Yeah.
When we didn't always have access to fraction manipulatives, for example, there were some really good ones that we could use on their iPad, and they could drag and drop, and they could do them in different shapes. So
Overlay.
Sometimes, they could be like horizontal bars, or they could be pizza slices, or lots of different ways to do that. Those were always recommend those easily. Not all of those apps and companies survived either. So a lot of them just kind of fizzled out, which is unfortunate because some really good ones were out there.
Well, and they fizzle out because, again, bigger districts are largely solving a different problem, or definitely solving a different problem than we were trying to solve. And so the default is to those, and I hate that technology is not useful as a replacement for something that is already not a good product.
Just right. Yeah. And even just, that whole gamifying of everything. It's surprisingly will do things even if it's not a game. I know you're all shocked, right?
I know. Well, and again, so many of the games are not authentically fun as games.
Right.
They've made math gamified, but it's not, we wouldn't choose to do it just as a game in and of itself. And so then how is that useful?
Kids, I do believe that a lot of people don't have enough respect for the intelligence of children because kids are smart.
Agree. Yeah.
If you're going to throw something at them and say, oh, look how exciting, it's a game. And they're like, yeah, this is stupid. I don't want to play this. Then you didn't gamify anything. You think that you did. And I'm not calling out anybody specific here. It's just a reminder of, kids are human beings. They deserve to be given some respect. They are a lot smarter than most people give them credit for. They don't want to be tricked.
And the curiosity is there. Why are we not capitalizing more on the natural curiosity, wonder, excitement of that light bulb moment of making the connection? I don't think ed tech developers give enough credit in that way to think they are so excited to figure out how the world around them works. Mm-hmm. We can capitalize on that, right? That's something that genuinely we would love for people, more companies to solve those problems because, or to come up with those kind of solutions, because that's something I would be excited to put into place and see more of in the marketplace for those of us who don't have your brain that naturally is so good at making those connections. Selfishly, like I would have loved tools that help me think that way as well as a teacher.
We have friends that are in ed tech solution businesses. Mm-hmm. Respect what they do. They are definitely looking at how can I help children? How can I help teachers? And with that mindset, they're actually the ones who are out asking the questions, interviewing kids, interviewing educators. Their products tend to be better. There are also a lot of entrepreneurs, and I use that term kind of lightly in this case, where they know how big an education market is, and they just wanted to jump on that opportunity because it looks like a really quick way to get some bucks in their pocket. They tend to be the ones that they don't review educators, first of all, because they just think that they know what the problem is already. Mm-hmm. They try to solve a problem that we don't need solved. So if that's your business, you're not going to get a lot of traffic from people like us because that's not what we're in this for.
Yeah. Yeah. And seeing all these AI, and I know you and I have a little bit different, I'm more of a lover of AI than I think you are, but seeing how many of these companies are rushing to just dump AI into the classroom.
Everything.
And in everything. It's true. It's literally everything. I think the heartbreak for me is we're repeating the same bad practices, but now we're doing it in an accelerated way because we have AI. And it's like, why are we're just doing something that's bad faster? We're making it easier to create a crappy worksheet. Is that do we need that? And so the heartbreak for me is I see that there could be so much potential for how this could empower teachers differently. Again, we are so centered on relationship that I see all these products looking to, now everybody can have their own AI tutor. And I'm like, I don't want kids to have an AI tutor. I want to empower the relationships in the classroom. I want to empower teachers to do that part better, but I don't want it to I don't want that relationship to go away because now the AI can just step in, because fundamentally, I don't think that's how we help humanity. And so I see all these tools further damaging the relationship that could be in the classroom, the collective intelligence of the class. And it's making it all this everybody has a siloed experience with a computer. And I'm like, I don't think that's where it is.
Please talk about the ELIZA effect for a second. Because, okay, so the ELIZA was ELIZA. It was a computer in the 60s that was simulating language and whatever in conversations, right? What happens to, we try to, I can never say the word, I can spell it great. Anthropomorphize.
I can't
Anthropomorphize something that is not human. We do it with our pets, right? We talk to our pets like they're little humans, and they're not, but they're still, sentient beings. They
respond back to me brilliantly, Michelle.
You can have my dogs push buttons when they need to tell us certain things, so they can communicate. I'm using an AI tutor. We go back and we think about the ELIZA effect. When what happens is humans start to give that computer, that AI tutor, whatever robot you want to put in there, Siri is a good example too. You start to communicate to that programming a human being. What we know about kids, again, they don't have the ability to understand abstract concepts at that level, the point where sometimes they forget that they're not talking to an actual human. They are relying on human for interaction. We have a huge problem. And we already have kids, people complain that kids are already too much on their phones, too much on whatever, too online. I'm not going to argue that point one way or the other, because it depends on the kid, and it depends on what your expectation is for your child. Right. Yeah. Lots of kids are online playing, role-playing games with other human beings. That's interaction, right? You take the humanity out of that, and now it is literally a piece of programming responding to your child who does not have the ability, the cognitive ability to differentiate that from a human saying something and a non-human. That is a huge problem.
I see the new AI video that you can literally take yourself and create video as yourself. And I'm like, oh, I don't think we're considering the implications.
Just because you can doesn't mean you should.
I don't know that we're considering the implications of what that does.
And again, now we're blurring the lines between reality and non-reality. And how do you help a child who still has a developing brain make those distinctions, especially if it's really hard to see visually? If you're seeing the same person's face, you're hearing the same voice, but it isn't actually that person. There are cases that I'm not going to bring up specifics, but there's been harm done to children. Young adults because of these situations. It's not a road we should be going down. And if people who are like, oh, it's already here, just get used to it.
I think we need to more thoughtfully go down the road. Right. I think we're rushing to put things in a marketplace for, let's be honest, money, because we are a capitalistic society. That's the primary driver of a lot of what ends up in the classrooms. However, I think in the rush to be innovative, to do different things, we're not being as thoughtful as educators to really say, again, the questions we ask: who is this serving? What is it in service to? What is it helping our students do that is missing? Is it solving a problem that we didn't have to begin with? And like I said, I am a lover of what large language models can do, and I enjoy interacting with them in different ways to solve different problems. I enjoy creating my own LLM that's trained on my stuff that can be a thought partner in different ways. That is different, me as an adult interacting with that, knowing what I know, interacting the way that I can. I can even understand the ethical implications of where things are being pulled. I can think through some of those things. With our junior high last year, we did an exercise where we were going through and creating a math game using AI to generate images. Led to this great discussion about the ethics of where are these images coming from, because while it's really cool and the kids are like, well, that's not quite what I had in my head, or, that's exactly what it did exactly. And we used it more as a descriptive writing exercise, where the more precise they got in their writing, the better the image that came up. However, we were talking about if you were the artist and you did not just get credit for this thing that is now in your creation, in quotes, right? How do you feel about that? Yeah. And it led to this interesting conversation. And I don't know that we landed in any one camp, because there was also good conversation. One of the kids brought up derivative music. Is that what it's called? Mm-hmm. And how that has always been a part of how we create things. The difference is we were creating the derivative, right? It wasn't a computer doing it. And the kids are like, but we're still a part of it because we're feeding it the prompt. So it was an interesting discussion, all that to say. We as adults can think through the nuance of all of that. Like you said, the kids don't have the full capability to understand what it is that they're interacting with on that level as they're interacting, and the rush to just push things into classrooms. And then again, you're pushing it into classrooms to do the lowest level of thinking. Mm-hmm. And that's what bothers me more than anything, is it's like, this wasn't even necessary.
It's interesting to me, again, that because we call it artificial intelligence, but there's not an intelligence there. So it's not even properly. It's a generation of facts, pictures, images, whatever it is that's being scraped. So, right, like you said, if you choose to train an LLM, the things that you've written, you're able to give consent in a way that makes sense, right? You're going and you're training this model to learn from your writing. It isn't technically learning. It is generating response based on what it is able to pull from what you've given it.
It's pattern recognition, right? Like
exactly. Yeah. So when we talk about, it's generated art. Well, it's not. There's no creative ability in these models that are able to create something unique. And actually, that's two words together. It cannot create.
Yeah.
It can produce and
generate.
Amalgamation of other things, but it cannot create. So when we stop to think again, okay, how is that impacting how kids see whatever AI bot they're using? Is it a language model? Is it something that's supposed to be, creating some art? And I keep saying that's not creating, right?
Generating art.
And go ahead.
And are they thinking, how is it changing how they're thinking about reality is what I'm really interested in, because that is going to matter to
absolutely
all of us, right? How we understand reality, what's happening, where things are coming from, creation.
They need to know where it's coming from. That's when we talk about Chat GPT. So I'll ask kids, when you put a sentence or a question or a command into Chat GPT and it gives you a response, where did that response come from? That was a question I asked the kids that I had last spring, and they were like, I don't know. And I said, okay, well, let's go do a search on a search engine. And we're going to go look up, whatever, like cities. They were cities of the future because they were doing their building of cities. And I said, okay, where did all of those returns that we're getting back from that search engine, where do they come from? So we had a quick little lesson about how it goes out and it looks for things that already exist that have those keywords. I said, okay, did the search engine create that? Well, no. I said, okay. Now let's look at ChatGPT.
It's the next version of kids citing Google as a source.
Right.
All right. And now it's the next generation of that.
Taking it back to, a math tutor, let's just take all the ethical pieces out of it for a second. If I'm a student, I'm asking the AI tutor a question that it is not trained to answer. It will find the next best thing. And now we have a bunch of kids who are not getting actual answers of whatever it is. And they're sometimes incorrect.
And the ones I have played with, and granted, I've not played with everything, so let's use that as our baseline. The ones I have played with are, again, teaching very in the very ways that we said, this isn't how we want to teach our kids math, because it's been trained on how many models of math the way you and I learned it.
Right.
And so it's not helping kids do the kinds of thinking that we value.
Mm-hmm.
And so it's like, again, does it meet our value systems? Does it center kids in the way we want them to be centered? Does it build relationship, or does it sever like these are the questions we ask, and I wish everyone was asking. Unfortunately, I see a lot of schools and educators wanting to innovate. Like it's coming from the right place. I do believe that. Wanting to innovate, wanting to make sure that their kids are getting the cutting edge, and that it's relevant to their lives and all of these things. I think the problem is we're starting in the wrong place. We're starting with the technology instead of starting with the individuals in front of us.
When we don't do that, when we don't look at the kids that we have in front of us, and I will always say kids interchangeably with students, I probably should be more specific, but we're not looking at the people in front of us. We're assuming what the needs are, and we're trying to solve a problem that isn't necessarily there. And we're ignoring the ones, and I don't mean problem in a derogatory sense. The issues that are in front of us, what do we need to help these kids learn? And if I'm making assumptions, then I'm, again, maybe targeting something that isn't a need, and I'm ignoring another.
Yeah.
That's...
Now value I could see it bringing is me saying, I need to teach order of operations. I don't really understand why it works the way it works, right? I don't understand why this is. Help me as the educator break this down and co-create is the wrong term. Co-generate, right? Let me give some prompts to help me understand, so that when I'm in, again, that relational place with my students, now I'm empowered differently. That to me is a better use of those tools than let's just give everybody their own AI tutor.
My pushback to that.
Let's generate worksheets. Yeah, pushback.
My pushback is there are already resources out there by way smarter people than a language model.
Sure.
I'm trying to remember, I need to, teach this specific concept, and I'm a little rusty on it. There are hundreds of really good math teacher resources out there that people put online for free.
Yeah.
That I trust them. Like, again, if it's Howie Hua or Joe Bowler or somebody like that, know that those are resources that I've used before. They've written really great books. You can go to them first, because my last issues with a language learning model is that they might put something in there that isn't actually true.
That isn't true. Yes.
Now I've passed it on to kids.
I would agree with that. I would also say, in my own thinking, I'm considering, we always want it to be contextual within the inquiry block that we're doing. And so I'm like, where does this go? Where could this go?
Yeah.
Right. I'm looking more as a, I don't know how to not make it human, but thought partner. Right. But I'm really looking at, like, help me riff on this and think about this in ways that I might not be considering it. But I agree with you. Like, you have to know enough to know when you're getting a bullshit answer.
We have friends that created a history website years ago, Girl Donks, and they specifically made it seem like it was factual at the top. Like the first paragraph, you're like, okay, yeah, that's pretty factual. And then as you kept reading through, like, this is not factual.
This is not.
They did that to help kids think about what's on the internet isn't necessarily always factual. What are some clues that I can get as I'm reading? So it was a really great tool to help. There was one year when I was teaching something, I think we were talking about exploration, and one of my kids found that website accidentally and used it as a resource. And I said, I didn't call that student out, but I thought this is a really great learning opportunity. Let's use this. I don't know.
I remember that.
Right?
Yeah.
And of course they were like, oh my gosh, I should have read more. And I'm like, it's okay. Now, you're not expected to know everything.
I mean, it was a great learning moment, right?
But because it came up in a search, they just automatically assumed it was a resource that they could trust. It led to a great discussion about how we can discern information, be critical thinkers, fact check, as well as what do we know to be reliable sources? What are some that we know we probably should question these? I think with some of the AI models, because that steps are taken out of there, you're not seeing, example would be Wikipedia. For years, teachers have said, don't use Wikipedia. And I'm like, no, go there, because there are citations at the bottom. That doesn't necessarily mean everything's factual, but I can at least check.
I am appreciating that ChatGPT started putting in source citing so that you can go back and say, oh, this is nonsense, or this is not a useful source for me, or whatever. That is helpful as you're interacting. And hopefully those tools will lean more heavily into doing that, so that you know, one, where things are coming from and how it's come up with what it's offering. But yeah, it's interesting to see sometimes where it will cite, and you're like, that is not what that source is saying, because it's kind of pulled this amalgamation together, and you're like, based on the question I asked, that's not actually answering this source is not a good source for the question I asked, right? And it's creating the answer based on that source, and you're like, okay. But I wonder how many kids, number one, and then teachers are actually going through and looking at that to ensure what they have is useful.
It's a whole lot of background knowledge and experience to pull from. And if you don't already have that, and again, unless we're really approaching using AI tools, if this is a learning process, and we need to be skeptical of literally everything that's coming back. It's actually a great exercise in how do I know? How do I search for this? And I find the same information anywhere else. But I think that because a lot of the exercises that I'm seeing some of these AI companies come out with, they're essentially saying, well, you could just use it like a search engine. And I'm like, no, that's a completely different.
I hope you're not doing
right.
that. Yeah.
We do have a lot of kids using that.
What's unfortunate is so many of the search engines have started using AI to generate things, and it's made them worse.
You've done any kind of search engine
really
search, right?
Frustrating. Yeah.
They were getting worse. And
I'm like, go back.
Even, I told this story in a previous episode, but my mother-in-law was looking something up, and she was like, oh, as it's AI. And I said, yeah. And she goes, well, what does that mean? So I was kind of explaining it to her. And then she said, well, does it always tell you when it's AI? And I said, no. So I showed her the recipe example where it was how to make macaroni and cheese, but they wanted the cheese to be stickier, a thicker sauce. The recipe from the AI model said to put glue in it.
Put some Elmer's in there.
And they're like, the viscosity will change. And so I showed that to her, and she was just like, what? Okay. So she's, in her 80s. Of course, that's not something that she's experienced. However, we cannot assume our students, just because they're younger and have grown up with this technology, that they are going to have any different of a reaction than she does.
We should call it like the Amelia Bedelia effect or something, right? Because people take it so literally.
How do you dress a chicken? Well, you put on a shirt and then you put the legs in the pants.
Exactly.
And,
like, I mean, that's a great way to introduce maybe some healthy skepticism or like giving you pause. And do we mean literally, or what might be wrong here? The other thing I thought was fascinating, and I wish that we had kids right now, because we got into this a little bit during the Sharing the Planet inquiry block, but we didn't have, I would love to make it the focus of that inquiry block, especially for the oldest kids, is how heavy the resource depletion is using some of these tools. And again, I'm all for using it if it's the best use of a tool, or if it's a I don't know, it's hard to quantify, but to make a dang worksheet, and we're going to use how much water and how like that, to me is just such a misuse of resources on every level.
If you
so I'd love to have the kids do kind of a deep dive into that side of things and do an inquiry really into the ethics, even the rights and responsibilities of using some of these tools based on what we know.
Resources that are being consumed at this point, again, a lot of people who are in technology fields, I don't like to say Silicon Valley, but again, people who do this all the time, they're like, this is not sustainable. It cannot continue at the rate that it is because we do not have the resources to put into it. And the more
by all means, let's make another garbage worksheet.
I mean, right? Here's the other issue. The number of people who are voluntarily submitting personal information into AI models. Again, we tell kids, oh, don't share your address. Don't. And yet we still have kids who'll do that, not thinking that their AI tutor or that bot or whatever it happens to be can actually help them. There's a huge news. I'm not going to get specific. People feeding an AI model all of their health symptoms, assuming that the AI model is so much smarter than all of the doctors that they're going to get
see a pattern the doctors don't see or something.
And let's not
is the assumption.
Sometimes that can be true. I'm not going to discount that hasn't happened because it has. However, when you voluntarily hand over all of your personal information into an AI model owned by someone who doesn't always
do not own.
You don't own it. You don't have control over that.
Yeah.
You've now provided personal data that someone else is using, selling, broadcasting. You've lost control of that. It's hard enough to help adults see that when it's happening. And there's just a very recent case where people are just shocked that, oh my gosh, I didn't realize that was happening. Now you take a child, and again, we're talking about underdeveloped brains. They're not there yet. They do not know the long-term repercussions of what might come from that. And I'm sorry. And
I honestly don't think we know that yet. Right.
We have enough to be skeptical about it. Right.
Absolutely. But I don't know that any of us have enough information to say what that could look like.
We've already given up so much of our freedom in how many, like, our images that are online, and some of us have knowingly done that, and some of us have unknowingly done that. And I think it's let's not feed that machine any more than we already have. If I have a lot of people who will push back and say, oh, they've already got all my personal information anyway. I'm like, who's they? Who's they?
That's the issue. Is it does feel that way, right? It does feel. And to your point with your mother-in-law, how much is AI all around us and we're using it unknowingly?
Right.
Because it's just become, everybody's rushed so fast to implement it into every single tool that we use.
All those end user agreements that would take you, right? 10 years to read.
10 years to read. It's like, how much are we unknowingly using these tools because they're out there, and everybody is, like I said, rushing to, AI is hot right now. So rushing to put AI in everything.
Thinking of Will Ferrell, so hot right now.
So hot right now.
From Zoolander. I think that, again, helping kids understand as well as adults that your personal data is actually your most valuable asset in so many ways, and that voluntarily handing over things that you don't need to. And that's something, again, with a lot of the apps and programs that schools are purchasing, hope that they have. I used to be on one of those committees where we do a lot of the due diligence was what of our students' data has to be given to this company in order for it to function properly. And then we would say, nope, that's too much. We can't do it because we have to protect our students. Now, because there's, just because a school says, oh, hey, use this app, and now it's going home. And now what has that opened up at home? I feel like there's too much one-to-one in a situation where now students and parents are being asked to sign agreements that they don't necessarily fully comprehend. Most of us don't, unless you have a legal degree. And even then,
I was going to say, yeah. they're hard to navigate sometimes. It's hard to parse out sometimes exactly what you're agreeing to.
Right. And
they get very crafty.
They do.
Yeah.
And you and I were both early adopters a long time ago. And it feels very strange for me to be pushing back against a lot of tech.
I know.
Because, right?
I know. It's funny because I feel like that's been a shift since we've met for you.
Definitely.
For me too. But you were such a let's teach kids how to use it well, which you still are in that camp. Less
not trying all the new things.
Less pushing to try all the new things, just to try them.
And I think too that comes from watching the ed tech space. The number of people who started companies because they were former teachers, former administrators, they saw a need that wasn't being met. And they found, in a lot of ways, it was like teacher management in the classroom for paperwork. So an ed tech tool could be used to help that, right? Not for managing students, although those came out too, but
those came out too.
And that's, again, I've said often, if there's AI that wants to manage my calendar and tell me, oh yeah, you have, Halloween, you've got 3 separate entries for Halloween on your calendar. I'm going to consolidate that to one. Okay, fine. Maybe that's an option I want. I don't want it, generating art for me or creating songs that I need because I don't want to pay for the rights. We spent so much time talking about fair use and copyrights with kids. And now we're just going to blow that all out of the water and say, oh, that doesn't matter anymore. I'm like, yes, it still does. It absolutely does.
It does to the person who created it.
Especially if that's their living. And we're not talking about, back in the day of scribes became obsolescent because of the printing press. Okay. But new jobs were created because of the printing press. So it wasn't like scribes were just left out to dry. So when I look at, AI is going to replace all of these things. No, it's not. And if you're using it to replace artists, musicians, photographers, whatever, you're not creating something new for somebody else to do. You're stealing work and you're not replacing and giving them another kind of job that's not there.
Yeah.
Sorry.
Yeah.
Getting all on fire here.
I know. As somebody who creates a lot, right? I want to have a say in how that gets used and what it looks like. And I don't want it to be misappropriated to do and say things that I would not, that I wouldn't stand behind.
Right.
So it is tricky because I both see how it can make my life better, easier in ways as I navigate zoning. I'm like, look at this document for me, pull out the pieces that I need to do first and make me a task list. Super helpful. I still have to go back to the thing and make sure what it's telling me is accurate. Right. While that is useful for the task I'm doing right now, that is not the same as, replacing that creative human element. I think the more we pull humanity out of our interactions, particularly in schools, the worse it's going to be. I don't think removing humanity from schools is the answer. I think, how do we protect humanity? Empower. How do we empower differently is useful. But again, I think we need to slow down and consider, why are we doing it? Who is it for? Who is it serving? What is it making better? Those are important questions.
Well, and I think we talked about this in a couple episodes ago, but one of the most, there's AI generated to help students write essay, and then there's AI generations to help teachers detect if a student used AI to write the essay, right? So they're competing against each other, but it's still on the market. I'm like, okay, we could completely remove the need for both of those tools if, instead of just having kids write essays to solve a problem of why are they writing an essay, give them some authentic writing
for
activities.
The teacher.
Right.
Yes.
If we have no use authentic writing activities that kids are using, then I don't need to worry about kids who are going to cheat because there's a purpose for that writing. If I look at Amazon example right now, there are hundreds of books that were written by AI. it's hard to distinguish which ones are which. But some of them, and the most, like a really famous example is foraging is a really big thing for people right now. Oh, it's really cool to go out foraging. Here's which mushrooms are poisonous and here's which ones are not. The AI generated books about foraging, which are selling, are wrong. And people are getting sick and dying because they're reading an AI generated book. So again, now we've got an example of, I want to teach kids to write. If I really want them to write authentically and I want to see if they're good writers, I'm going to keep AI out of that loop and instead give them a reason to authentically write rather than just write an essay that nobody's going to see but the teacher and they don't even care about it. Find what they care about. They will write. I mean, how many of our kids wrote books and novels and how-to manuals of things, pages and pages and pages long because they were so excited to write about it.
Yeah. This is an argument that I have often with some high school teacher friends that are so worried about AI writing everything that everything they're turning in is AI. And I'm going, because nothing that you're giving them has any value. They don't see the value in the assignment that you've just put in front of them. And I don't know how to help you. Like if it's a garbage assignment, well, why do you care if AI did it or not? Like, I don't know.
I mean, they were being resourceful, right?
They're being resourceful. Yeah. And we also live in a culture that tells them to be as productive as possible, hustle culture, all of these things that are sending the opposite message of sit and slow down and do something thoughtfully. And so why are we surprised when and the number of teachers who are grading with AI and writing grading comments with AI, and you're like, okay, how is that different? You're doing the same. Right. Like, we can't speak out of both sides of our mouth. Again, that's why it has to come back to, what is it that we value first? And for us, we value students. We value their voice. We value who they are and who they're becoming. Okay. Is it in support of that? Because if it's not in support of that, we're not going to put it in.
We're not doing it.
And to me, it's really sad. I feel like so many of the tools people are rushing to right now are taking us further away from that relationship and that value, because we don't have to know kids if the AI is just going to do it for us.
And what does it look like at the end of 12th grade or whatever? What does it look like when you have kids who've been basically rushed through? Doesn't feel like it's been rushed through for them. 12 years is a long time, but what is the portrait of the student? And I know that we've done that quite a bit at Anastasis. We have a portrait of an Anastasis graduate. This is what it looks like. And this is what you can expect. So if we're only basically conceding that we're going to just let something else decide what our kids look like, what does that mean for post-secondary education? What does it mean for the job force? What does it mean for being a citizen? I know we talked a little bit about that last week too. How do we expect our kids? And this isn't about keeping up with other countries, because
no,
this is not what it looks like.
Or the GDP,
no,
I don't care. Yeah.
How do you have a happy human being who feels fulfilled and wants to be an active citizen, contributing to whatever that means, an active part of the community, so that we are
and understands that they're a part of the community? I think this is part of what worries me about this dehumanization in the classroom, is when we separate people and they're separate kids, right? Everybody's getting their own separate education from an AI tutor or whatever that looks like. You've now fractured community outside of the classroom when we forget that we belong to each other, like we said, and that what I do impacts everybody else. What you do impacts everyone else. I don't know that schools are explicitly paying attention to what that looks like beyond the classroom space. So while it may make a teacher's job easier if everybody's got their own tutor, and I know it's being sold as, and you'll have more time to spend with each individual, which might be true. I don't know. I just know that what we see, the magic of what happens at Anastasis is the connection of, like we said earlier, the collective intelligence of what's going on in the classroom, the seeing things from other people's perspectives, the understanding that we get when we're in a room with other people, and when we can value each other beyond just what we produce.
Humans have human moments. There, how many times, and again, it's not efficient, but humans are not efficient in how they learn or how they live or exist. So if I have a classroom full of kids and they all have their own AI tutor and I'm doing paperwork, I guess, and now there's a kid.
I think the idea, Michelle, is that you're one-on-one with another kid while the others, and we know realistically
that's not what's going to happen. It's because what they'll end up doing is making those classes bigger and bigger and bigger because everybody already has an AI tutor, right? It's all individualized.
We are seeing this in real time in Colorado as schools are being shut down and combined at an alarming rate.
Right. So now you've got,
really does worry me.
You've got kids.
Because I don't know how teachers do it, honestly, without that tool.
I don't know. Honestly, I'd rather have a classroom full of 50 kids and not have to be working with an AI tutor for each individual student, because those are going to create more problems than they solve. You might think that they're delivering curriculum, but again, you've got kids learning at a rate that maybe an AI tool can't figure out. And then what do you do when that kid has a human moment? They didn't have breakfast this morning and can't function. Now what? It just creates more problems. And the snowball effect here is going to be huge in how we're going to see different problems arising in classrooms that are created by something we thought we were solving.
I really do worry about the social, emotional implications for individual students of not having another human seeing them.
Right. And learning is extremely social. We know that. We've experienced
so social.
That.
Yeah. I don't know the answers. I know that on one hand, I really enjoy having access to some of these tools, and I have found them to be personally useful. I can see how they might be used in a classroom to empower teachers differently. I don't know that that's what I'm seeing on a large scale right now. The only benefit, I can't remember where I saw this statistic, but I'm not even going to say it because I'm not positive where it came from. An article I was reading about AI in education was talking about how 32% of teachers said that they were using AI tools in the classroom or were using AI. What might be funny is to know, do they even know if it's AI powered? You know, I don't know if that has been considered. But 32% have said that they were using some sort of AI, but it's a very small percentage. I want to say 12 who's actively using it on a regular basis. That makes me feel a little bit better.
Yeah.
Of just, it's not maybe as widespread as it is in my brain, because you and I kind of exist in this ed techy space online where we see a lot of the first to use folks. And so it feels maybe bigger in my mind, like a more widespread, everybody's doing this,
right?
Then maybe it really is. But I do wish people would start with the values and consider from that standpoint.
Even if we take it back to how we started this episode with thinking through math and what it is, if we're using a bot to help us teach, what can be taught through, an exercise that's on an app or on paper and pencil versus the things that we can manipulate, the things that we can go out and experience, going out and taking pictures, all of those activities we discussed. You can't really do that with a bot. So
and to me, that's where I'm like, in an inquiry-based classroom, these tools almost don't even make sense.
You can't.
Because it's not contextualized. It's not.
Right.
Now, again, I think about them in a little bit different use case where, as an educator, using it imperfectly as a thought partner, brainstorm, here's the inquiry block, here's what I'm wanting to help kids understand, where might a connection be that I'm missing.
What did I already write about this?
Right? That to me is useful, right?
Yeah.
Or, even we've got 14 years of inquiry curriculum and me writing and things that I don't always remember that we've done, we did this brilliant thing. We made this connection before that might be useful here. That to me would be a better use case for using that technology in an inquiry-based system. That being said, the tools I see coming out,
they're not that.
Would not be useful for us in the ways that we approach learning.
And I'm going to also say I don't think they're really useful for most classrooms, including traditional models, because
it's just replacing bad with bad.
It's again assuming a need that may not be there, and when you assume a need, you ignore something that is real for something that is imagined.
Shoot, I hope people will slow down a little bit and really consider. We have said that all the way through with ed tech tools as we've seen them pop up. And again, creating a complicated worksheet is nothing new, right? We have had tools that replace the bad worksheet problem set with a computer version.
Anytime we saw things that were more teacher-centered than student-centered. Mm-hmm. So I was thinking like smart boards.
It's a good indicator. Yes.
Right? It ended up being a very, very expensive whiteboard that was not used to its full potential most of the time. And then even for the teachers, I saw teachers use smart boards in just like fundamentally miraculous ways, right? But
I claim some of those ways because I had the school that went full on Promethean, and I was like, well, let's use this for something. Like if we're going to use it, let's use it for something cool.
But then where did that go? Right?
Probably with me when I left. I mean, that's my guess.
And they were expensive, and I'm like, okay,
so expensive.
If it's contributing to student engagement and action, not just sitting and being engaged, but then I could see, but that's not how it ended up being used in most places. And for some, they did not use it any differently than a whiteboard. So it was very expensive.
Literally a whiteboard in most classes.
Very expensive. You could play a video through your computer on it. I saw lots of people do that instead of having a projector. So, okay. That's just an example of we tried to solve a problem that wasn't really a problem. We just made it more expensive. And I think that's what we're seeing. And again, a lot of people jumped on board and it was the hot topic for a long time, and it's no longer a hot topic. That's typical of, fads in American education anyway. But are we going to waste a lot of money doing something like that when it's not changing?
Again, resources, like actual resources for something that's so not necessary.
Exactly. Yeah. So that's
the way that it's being used.
I always think about, where's the money going? How is it being used? Is it really going to benefit the students in a new and better way? Or is it a substitution for something that just costs more?
Unfortunately, I think those who are making decisions are making it based on money in different ways.
Sometimes those salespeople are good.
If the AI can do this, I can eliminate 2 positions. I think unfortunately there's a lot of that thinking of, or teachers are hard to find right now, right? Hiring is difficult. And so I think they're solving an immediate problem maybe with a long-term solution that's going to be detrimental. So, gosh, I hope people will just take a breath. And if we could do nothing else in education but to give ourselves a beat and to consider where our values, what do we value first, and then base every decision on that. And I know a lot of schools say they're learner-centered. Maybe we should do an episode on this. You can't claim learner-centered and make the decisions we're making in most classrooms. I know I believe the heart is there to be learner-centered. I don't see the evidence to support that is true. in a lot of places.
Agreed.
And a lot of it is district or school decisions.
Right.
I know it's not classroom specific decisions, but sorry, I don't believe you. You value curriculum first, or you value a test first. Mm-hmm. How do I know that? Because you're buying curriculum based on a dumb test, or you're, like we're making decisions. Anyway, that's a whole other ball of wax for another day.
We talked for a long time today.
We did. And we probably could keep going, but we'll give people's ears maybe a rest. If anybody made it this far, drop us a comment. Tell us you made it to the end. I know we should do Easter eggs of some sort that help us know that people stuck with us this long. So if you did, kudos.
Our emails we used to send to families that were very, very long, and we would put song lyrics at the bottom just out of nowhere to see if they'd ask us, like,
what does the fox say at the bottom of the email? And then we'd know, because the parent would go, I was with you up until what did the fox say? And then I lost. I don't know what that means. And we're like, it means you made it to the end.
Kudos.
Oh my gosh. Funny. Okay. Onward. Hey, Michelle, where else can people find you online?
I blog at avenue4learning.com, and the 4 is the actual number 4, not the word 4, avenue4learning.com.
And you can find me at dreamsofeducation.wordpress.com, which is my original blog. You can also find me at ktsplace.com, which is where I share a bunch of resources and kind of projects that we're currently working on. And we are both on Blue Sky at the moment, but not as active as we once were on our favorite bird. Come find us and connect with us in other places, and we look forward to connecting with you.